Hello and welcome to the third part of the level builder tool. And in this part we're going to create a more complex wall system. So here am I back in Houdini, and I'm going back to where I created my current wall system, which is here. And I'm going to make some changes to this because I want to make it more complex. So I will keep this system that I've built, and I want to sort of build on this further. So what the idea is that I'm going to implement is that this wall piece over here will be gone, but I will still be using the bottom and top models, and I will be replacing this wall piece that I just removed with a complex wall system made out of modular pieces. So over here I'm going to make some space, and I'm going to bring this down, and I want to merge these nodes together, so the groups. And the reason why I made these groups is that after I merge, I can still decide what is the large piece and what is the small piece. So from this piece, I want to make a decision if it should be a complex wall system or a normal wall system. So again, here as example, sometimes I still would like to have my old wall, but sometimes I want to get a more complex look on this, like for example here. So I want to randomly select points that are going to either represent the wall or the complex wall. So I will be using a group range for this, and I'm going to set this to points. So points, and in this group range we can then, for example, call it the wall split group. And in here I'm mainly interested in using this setting over here and pressing 2 in the off value. And now we have a few points selected. Now these are quite selected by a pattern, and you can see that they're always like either skipping 1 or 2 in my case. And I want to use a sort node here. So with a sort node we can then change the random. So if I just play around with the slider and have now a more random result. So before I had a result that was quite consistent, like it's skipping 1, 1, 2, 1, 1, 2, 1, and so on. But in here with the sort node, it's getting more randomly, like it's skipping 2, here 1, here 3, here more, and so on. So now I can use a split node, and I can split based on this wall. So I'll use the wall split group, and I can now split on this. Make sure I'm going to set this to points to be sure. And now we have the complex wall and the normal wall. So let's restore my normal wall first. So this is my normal wall, and I'm going to use another split again, and I'm going to split based on the larger pieces and smaller pieces. So large pieces or small pieces. And I'm going to plug this in over here. So I have restored my original wall system. And from this point here, I want to make a complex wall. So either we can also place a null node, for example. We can also, for example, do this, and from here, let's make it complex wall. And what I would like to do is the following. I want to use a loop, and I'm going to use it for each point. So I want to loop over each single point, which is in this case 26, and I want to create a loop that creates a random shape. So let's create a grid. So grid, and it should be a grid that's also 8 by 8. And let's also fill in the row and columns too. And I'm going to copy this grid on my points. So copy the points in here, and let's fill it in here. So now I have just copied a grid on the points. Now let's also put this in the right orientation. So let's change this, and that seems the right orientation. Now what I want to do now is I want to think about how can I create a more random shapes in here. If you have installed the lab tools, we have a lot subdivision, and I want to place this over here and plug this in here, and you can see that we have automatically now created these random shapes in this. So that's already one step in the right direction. And the only issue now here is that they are not really random. You can see that every time it's the same pattern. Like if you just look at the corner, you can see these two long pieces and this bigger piece. So it's just the same step over and over again. And that's why I sort of create this loop, so we can use the loop to create variation in here. So how we can create variation is we can, for example, change here irregularity. And we can do this by asking the metadata. So click on this button, and now we have this node. Now from this point we can access this node. We can ask certain information. So make this bigger. So I'm going to ask the details from the node that I just created, which was called for each loop metadata. And I want to access the iteration numbers. So iteration number, and I fill in 0. So now we have accessed this iteration number. So it will go from 0 to 1 to 2 to 3 to 4 until we have all the loops done. But I want to use this in a random value. So I'm going to type in rand, and this will then create a random value. So press apply. And let's see what my loop will return. And now, as you can see, we have now a more random pattern. So each copy has more variation in them. So that could be really useful. One downside now is that if I move my curve, it's going slower now. So that's the little downside. I have a little fix for this, and that is by using a custom subplot division. So in here I have built a more custom system, and when I now go to the base curve, this goes faster. And you can still see that each panel has different variations. So this works a bit faster. Now you can also build this if you want to, but it's a bit more complex. It will require some facts knowledge. So what helped me a lot before creating this was this video, which you can follow here, this tutorial. And they will be creating as end result this same system which will return this pattern. So this can be useful if you want to have the same system. I made a few tweaks to the system that helped me later on to filter out models, because here also an important step is I will be fusing all the spaces to one. So if you're using the subplot division, you need to do the same. We're going to fuse all the points here to grid space 1. And the reason for this is because my modular models will be working with that the best. So over here I have specific modular models that are, for example, in this case is 1 by 2 in size. This one is, for example, 1 by 3. This one, for example, is 2 by 3. So I have built these models with in mind that they have a specific size that I want to also use in my system now. So here again, the fuse is then used to build these pieces that are, for example, here 1 by 2 or 2 by 2, or here 1 by 3, and so on. So they have this very specific size, which I'm going to use then later in my system. One thing that I didn't solve was also here. I have currently overlapping pieces because all the pieces are the same size. So I have pieces all that are the small walls, but I also have pieces that are the big walls. So I will be using a system here to switch automatically between small and big walls. So what I did to do that is, before I start the loop, I will be creating an attribute, and I'm going to call this attribute the large parts or large walls. So large part. Then this is going to be a point group. It's going to float, and I want to give it the value 1. Now this large part should only be value 1 when we are in the group of the large wall. So we're basically saying that every point in the large group will also have an attribute called large part. And now I can access this by point. If I take my geometry, I can now see here that my large part is 0. But some parts are, for example, 1, some are 0, so I can use this. So we'll be using this in a switch node. So either the switch node, it will be either value 0 or either value 1. So I can switch between two shapes. And now I want to ask the value from the for each into the switch. And I'm going to create a spare input, and I can drag and drop my for each node. And in here, I can now type in point, and I can -1, and with the -1, I'm saying look into the spare input. Then I will be saying 0, look at 0, then look for something that is called large part, or the large walls, and the default value is 0. So when this is filled in, it's going to automatically switch from 0 to 1 based on the value that we stored here in this attribute. So when it returns 0, it should be the small wall. So in here I have my wall, so it should be size 4. And when it's a big part, it should be the bigger wall, which is then size 8. So I can have two different shapes as input. So let's test this out. And this sometimes might be hard to see because we are creating all this geometry. So let's place down some color nodes. So I will be coloring, for example, here, this wall. Let's make it orange. And I can see that some parts are called orange, which are the smaller walls. So because of this system, it's not fully colored orange, but I can see that a few parts are being colored orange, and that seems to work. Now I also want to make sure that my shape is clean on the grid, and I'm going to use a match size node for this, or you can also use the axis line. You can use one of both. And I want to make a translation. I don't want to change the X and Z, I only want to change the Y because I want to make sure that these shapes are a bit better. And I want to change here this to minimum position. And now they are placed better. So the reason why they are higher is because my original points are also higher. So I can again use the match size over here. And I can also set these points to min. So now they are perfectly controlled on the grid. The reason why I'm making sure they are perfectly aligned is later on I can, for example, use a transform, and I can, for example, do this. I can rotate my shape based on the snapping point here, based on the point they are being copied. If I go here into my Unity scene, these walls are also having like a small angle, like a 10 or 15 degree angle. So I also want my random system to also have like this small angle, so we can control also how the pieces are being rotated. So that's pretty cool to then include in here as well. But for the moment, let's keep this on a side. Everything is going well, and let's continue then with the system. And so either you continue with a custom system, or you can continue here with some of the simple divisions. One of the two will be working. What we are next going to do is we're going to measure the area. So plug in the measure node, and the measure node will return certain values on how large pieces are. So as you can see, based on the size, it will return different values because it's calculating the area. If I also open my attribute spreadsheets, I can now see also the area, and each primitive has a certain area value, as you can see here. Then when I have the area, I want to add a normal direction. So in here, adding a point normal. So we have to direction where my primitive faces. Then I want to use a facet node. And in here, what I'm going to say is that they are unique points. And this will work nicely with a primitive node. And what I'm going to do here with this primitive node is I'm going to do a transformation and I'm going to lower the scale. So as you can see, we lowered the scale, and when we set this to 0, we can calculate the middle point of each primitive. So before, what I often did is I used like a for loop, so I would loop over each individual primitive and do a fuse. That's also a good way. This is also another way that you can do it. So you can use a facet node and use the primitive node with scale 0. Now one more thing here that we need to change is at the bottom we need to remove this normal, because I always want to keep my original normal information. I don't want it to be recalculated or something like that. So then I have a bunch of points, and what I'm going to do next is I want to convert my information from the area to my points. So it's currently stored in primitives, but I wanted to have it in points. So I will be using a promote attribute, and I want to change this from primitives to points. So make sure I'm going to select the area, and now it's gone in points, and now it's gone in primitives, and it will be found now in the points. So I can access this in points. Then I'm going to make sure I'm going to fuse the points, because there are a lot of overlapping points. So fuse them, and again here disabling the remove repeated vertices and also the normals. So I have this correct direction. So this is then the basic output. So we have our points, a normal, and we can access the area size. So what I want to do next is to show you that we can use this area size to copy our models on. So we'll be using a blast node, and in this blast node I can then write an expression, and I can ask the area size, so at area, if it's for example value 2, I want to see it. So right now nothing really happens, just make sure you set it to points, and now something happens, and we need to also delete non-selected. So if area is value 2, as you can see here also in my sprite sheet, they are shown. So this means that the pieces are 1 by 2. And I can use this further for my other values. So if area is for example 3, I know that my pieces are 1 length and 3 width. And we can just keep building this as much as you want. So in my case, I have 4 different area sizes. So I will do this one more here for number 6, for example, which is this piece, which is 2 by 3. So 2 by 3 is 6 in area. So I can filter that out. And then I have one more, which is for equal pieces. And for equal pieces, I'm just gonna copy this and paste this another time. And I will be using the same values I did here. So 3 and 2. So if the area is 6, 3 or 2, then just delete it, which in this case is everything. So this will be a equal pieces. So these are my equal pieces, so 2 by 2 or 1 by 1 or 3 by 3. So everything else will be going out here. And we can already, for example, use a copy to points, and we can test this out if you want to. So in here, let's make this a 1 by 2. And we can see that it nicely fits over there. So let's plug this in my copy to points. And I have now this result. There is one little issue I have now with the system, is sometimes my 1 by 2 piece is, for example, placed in the height, so the long side is in the height, but sometimes on my 1 by 2 piece, the long side is placed in the width. So I also need to find a system that I can rotate it when it needs to be rotated. So I'm going to create a small system that says if it needs to be rotated or not. So we'll go back over here, make some room. After the measure over here, I want to loop over each primitive. So for each primitive. And so we're going to loop over each primitive. I want to use also a wrangle. And in this wrangle, I want to filter down and I want to look at the bounding boxes. And I'm going to create a vector called bound size. And this is equal to get bounding box. So the size from itself, so 0. Then I want to create an if statement saying that if bound size dot x would be bigger than the bounds dot y, I want to create a group. So I'm going to say set point group. So I want to use, and I want to create a point group on itself. So 0. Then I want to name it, which is going to call rotated. So this will be everything in the group rotated needs to be rotated. And I want to store the current point number. So current point, give it a value of 1. And I want to set the value in here. So we're just getting the bounding box. We're comparing if the x or y is the biggest one, and then we create a group called rotated. And I'm going to continue plugging in this in my system. And actually, because of the loop, we don't actually need this facet node anymore, because the loop will automatically split the pieces anyway. Then afterwards, after this fuse node, we still have access to this group node, and I want to split my points if they are rotated or not. So I'm going to, for the moment, put this on the side, and first of all use my split group in here, and I cannot access my group, and that is because I don't have any pieces that needs to be rotated. So in my case, I'm just going to copy this name like I originally typed it and paste this in here. So it's not showing up anything at the moment. So that means that the second output will be the normal points, or the points that don't need rotation. And the first input are the points that needs to be rotated. Now, since Houdini 18, there is actually a node called orientation along curve. And I actually want to use this on just points. So either you sort of like could type an attribute or some vex to create the orientation. But with this node, we can actually in here go to the additional rotations, and I want to use the first one, the roll or twist, and I can then use this. For example, we need to rotate it 90 degrees, so I'm going to fill in 90 degrees. Now we also need to copy this on the other side as well, and I'm going to fill in 0 in here. Now, to explain what is happening, I'm going to open the sprite sheet over here, and what is happening is that an extra attribute has been added, which is called the up vector, which you can see over here. So we have our normal, and we also have an up vector. So by default, Houdini will always create an up vector, which will be 1 in the y. But in my case, when I rotate the point, let's take this over here, we can see that my up vector has now a very specific direction. So if we can control the up vector, we can also control some of the rotations. There are of course other ways to control orientations, but since Houdini 18 with this menu, we can easily add some rotations in there. So now I need to merge the points back together for here. And let's plug that back in like this. And now we should have the correct orientation. So we could always check this with a copy to points and see if that's correctly implemented. And like I mentioned before, we can either use a custom system or we can use the sub-lot divisions. So if I would plug this in over here, so it's going to do the similar thing like my custom system, but a little bit slower. One more thing you can also do here as a fill system, if your irregularity would be, for example, like this, and when you fuse them, some pieces might be too large. So what I also did, or what you could do as a simple save system, is using a divide node. And in the divide node, we're not going to triangulate it, but we're going to use the breaker polygon features. So I know that my biggest piece should be the size 3 or 3 units, so I will fill in here 3. So because I only will be supporting until unit 3. So if you look the result and compare it, we can see that there are some extra lines added just to support the piece a bit more. So if I plug this in, we can now see that there are some extra edges added. Just to be sure we are staying in this maximum unit of 3. I think this is also better viewed when we, for example, take our larger primitive. This already, for example, happens over here. So this is probably a 4 by 4. I can support this by using my 2 by 2 or 3 by 3 and just scale it. Or what we can do is then here having this save system that cuts some extra edges in here. So this is then 3 by 3 and a 1 by 3. So that's a simple solution to the system. So the next step is I have now the points where I want my models on, so I need to create an instancing slot. So I will be going over here and I'm going to copy paste these nodes and change the naming. So I've done this before and I might skip this part, just going to do this 4 times after each other. So copy pasting and changing the prefab name. So in here I did that for all 4 of them. A few things that we need to improve on the system is, first of all, I'm going to select every clean node, and we also need to include now the up vector. So don't delete the up vector because this controls the rotation. Then there is another thing you can actually do also here, is we can use an attribute random to randomly place prefabs. So I have actually built multiple versions of this model. So I have 4 versions of this, and we can use an attribute random. So in this attribute random, what you need to do in this attribute random, first of all, make sure you set it to, of course, the Unity instance. Then we need to set this to custom discrete. Then this is a string because we need to set the path, and I'm just going to click clear, and now we can add as much paths as we want. So in here you're just going to have to type in your asset paths to your prefabs. So we can keep adding with this plus icon multiple paths, and we have also a little weight on how many times this version should use compared to the other one. So this is quite useful if you have multiple models to be copied on one point. So in here I already set this up. So it's just the path to my model. So in here it's called wall part 3, and in here it's called wall part 3 P7, so it's a different piece. So I've done this multiple times here. Now merge this together with the merge node. Then also place the transform node to rotate the result. And I'm going to expose the x-axis or x rotation. So at assets, the x rotation. So rotate x walls. And let's also clean this up a bit with the model walls. Let's go and bring this over here. Press accept. And I want to test my system, and let's bring everything down over here and plug this in here as well. And now I have rebuilt my asset, and as you can see, so some of my walls are normal, some of my walls are the random wall pieces. And this slows the tool also a bit down because we're also doing that complex calculation for the walls. And now let's rotate my walls. So let's say I want to rotate it 13 degrees. 2 seconds later, we now have a wall that also follows nicely my original panels. And we can go more if you want to, like if you are going extreme, like 20, you can do that. You can also do that. Now, some parts there are still holes in my wall. So this piece needs actually to be scaled up like this. And same with this piece also needs to be scaled like that. So we have a wall that looks like this. So what does this mean? Is that sometimes, like in here, this piece is nicely fits nicely in my system, but sometimes over here, when I reset it to original scale, which 1, it doesn't fit nicely. So I need to scale this up automatically. So in Houdini, I can define certain scales. So I'm going to create here a small system to then say what the scaling should be. So I know that my problem lies with the equal pieces, because sometimes my piece is, for example, 2 by 2, but sometimes it's, for example, 3 by 3, as shown here. So I know this is 3 by 3 and this is 2 by 2. So I need to define the scale. So I'm going to use a wrangle, and in this wrangle, I want to make an attribute called pscale. And pscale is an attribute that is recognized in Houdini by default. Then I want to get the square root from the area, so at area. And I want to divide it by 2. I know that my piece is equal, so if it's a piece that is 3 by 3, which will return area 9, so with square root, I can know that it's 3, so my size is 3, and I'm dividing it by 2, because my original piece here, so this is a 3 by 3, and I need the scale 1.5. So that's why I'm dividing by 2, so it fits nicely in Unity. So I have now set my pscale, and also over here, we need to make sure we set something called pscale over here. And as you can see, my pieces are scaled, but everything else is gone. And the reason for this is because we set a pscale value to these pieces, but not to the other pieces. So what happened is that these models have certain scale values, like 1 or 1.5, and all the other models, they have the scale 0, so they are basically scaled to nothing. So what I have to do is I have to create an attribute called pscale, filling in the value 1. So everywhere else, I'm going to merge this, and I want to create a pscale value for the other values. So that should fix it. So also here, copying the pscale, and make sure you're gonna set this to all the other information over here. So I will be, to make it easier, make a new merge, set this over here. This line needs to be redirected to this part, and merge this over here, and now I can use the pscale here. So we're basically setting all this input to pscale 1 and save. And now everything is back with a nice scale. You can see my wall is nicely fitting in 1. I can also see here that my rotation is maybe too much because I'm clipping with the other wall. So I might go back to, I think it was 13 or 14. Now there are a few more things we can improve on this wall. So everything is nicely aligned, so we can add some more variation or depth. So I can go back over here to my wall system, and after the fuse node, I can create a jitter, a point jitter, and this will, if you play around here, we can see we can push our points away from each other. And I'm also going to disable update normals because we don't want to override our normals, like you can see. And we only want the jitter to be happening in the z-axis, so 0, 0. So what this jitter is doing, as you can see, so some pieces are moving forward, some pieces are going backwards. So that's nice to control. What we can also do is we can use a peak node, and a peak node will move points along normals. So if I disable here recompute normals again, we can see that we can move the points along their normal. And these values I will be both exposing. So here, going back to my menu, and let's add here the scale, and here the peak value. Let's say wall pieces, and let's say wall pieces move, so we can move them back or forward. Now we can also make a folder for this, and we can group these values. And one important value I did not expose yet, and that is, if I go all the way back up here, is of course my random seed, so I can have different variations instantly. And I can also expose here my group range value, and with this value I can say if I want more or less of these pieces. So I can call it the ratio complex wall. So with that we're going to control if there are more or less complex parts. So now I've updated my tool, and we can already see that there's some little variation going on, and we can, if you play around with the jitter amount, let's say put this to 1.5, we can go more extreme like this. So we can do that as well. Then we can also push them backwards, so let's maybe put in value 1, and they are going forwards, so -1 for backwards of course, and now they are back. So maybe that's just too much, but maybe we can fill in a small value like 0.2 or 3. So then we have pushed them a bit backwards. And now I can, for example, go here with the seed, click on the seed value, and now we have a different layout being generated. So you could just play around with the seed until you get something that you like more. Or of course we can play around with the ratio. So if we increase this, we will have less of these wall system, complex wall systems. So if you put in 5, I should normally see now none or 1. So we have now almost none. So we have a few here, there, there. And when we set this to, for example, 1, we will have everywhere a complex wall, like we can see here. But I like to have some variations in there, so I like the value 2. Now one more small thing I want to end the tutorial with is I want to continue this part here, like the end part. I want to continue that part over here, also the top one, so it's nicely integrated in my tool. So I want to go over here where I created my original wall system. I'm gonna make some room, and what I will be doing is I'm gonna copy this part, place it over here, and I'm going to change this input to the first input, so where we get the complex wall systems. So instead of using my wall model, I'm going to use a different one. So I'm going to change the names, so I know I only have to change that number, and let's just plug that in here in this merge node. We're building the asset. And now I have this part as well. So this is just a model with a top piece and a bottom piece. And this is automatically placed. So it's basically the same model like this, but without the panel, of course. And now it's nicely integrated, so it also has this lightning bar coming up from the bottom. So it's nicely integrated with the scene. So and that was it for this part. So we have created complex wall system, and I hope you enjoyed it, and thank you for watching.